So in this lesson, or in this video, we're going to learn how to add mixed fractions pictorially. So we're going to use fraction circles and fraction strips and number lines to add them. So first of all, when we add two fractions together or two numbers together, the numbers that we add together, like in 2 plus 3 is equal to 5, these two, the 2 and the 3 are called the add-ins. The 5 would be the sum. So let me just erase this. And we're going to start with the add-ins. So in the very first add-in, we have 1 whole and 2 of the 5 that are shaded. And in the second add-in, we have 3 of the 5 that are shaded. Okay. So now if I go shade 1 whole, sorry, this is going to be very ugly. Okay, and 2 of the 5. And then if I switch it to blue and shade in all the blue ones, well, we have 2 whole pizzas that are shaded. So 1 2/5 plus 3/5 would equal to number 2, or will equal to 2. So let's start with 2 wholes and 2/3 and 2/3. Once again, if we shade, that whole thing would be shaded, that would be shaded, 2 of these would be shaded, and then we have to switch over to blue, that one would be shaded, and that one would be shaded. So we have 3 wholes and 1/3. So now I'm going to give you the addition sentence, and now you're going to do the shading. So our first add-in is 3 1/4. So we have 3 wholes, and I'm going to shade in already the sum as I'm shading in the top. And again, shade in that one, shade in that one, and 3 wholes, and 1/4. And I'm going to leave this one yet. So remember, we have to shade that one in. Actually, we can probably shade it in. I'm going to shade it in over here though. Okay, just because I know I have 1 whole here. So we have 1 whole. So now if I have a whole that's divided into 2 and a whole that's divided into 4, it's the same thing. It's still equal to 1. So let's just shade in that 1 whole. But now we have 1/2. Remember, we can't add fractions unless our pizza is divided into the same number of pieces. So what we have to do is we're going to take our halves and we're going to turn it into fourths. Well, now instead of having 1/2, I have 2/4. So now I'm going to shade in 2/4. And we can see just from the diagram that we actually shaded in half the pizza, which is fantastic. So now we have 4. So this is equal to 4 and 3/4. The rule still stays the same as proper, like we learned in lesson 1, 2, and 3, as in mixed. We always have to make sure that the pizza is divided into the same number of pieces. So let's go on and see. Let's try this one. So 2 7/8. Again, 2. They're divided into 8. 2 and 7/8. Love my shading. Okay, and then we have 2 and 3/16. So this whole one, and I'm just going to draw a line because it's very hard to see. Okay, so there's your 3/16. So before we can even continue, we have 8ths and we have 16ths here. So we have to change or divide each of these into 16ths. The way we do that is by cutting each in half. If I take 8 pieces and if I want 16 pieces, I have to cut each of them in half. And now I have 16 pieces. Okay? So we have in our sum, this one is all, this one is all. I'm going to shade my all my whole ones first, a little bit easier. Okay, so we know we have 4 total. Now we have 3 of the blue, 1, 2, 3. And instead of having 7 of the 8s, it looks like we have 14 of the 16. Okay, so we have the entire thing except for these 2. So that's 14 out of 16. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So this is the exact same thing as saying 5 and 1/16. Okay? And that makes sense. If I need 2 more here to fill this whole pizza, I'm going to take 2 of these and put them in there. That makes a hole and I'm left with 1 more. Perfect. Okay, well, let's switch our thing to fraction strips. And I have to apologize already because my fraction strips are not very clear. So I'm just going to add in what's not clear just so that you guys can see them at home. Okay. There, I think now that's pretty clear. There's a few more down here, but these are holes, so I think we're good there. Okay, so our first add-in. Now instead of, fraction strips are exactly the same as fraction circles, but instead of dividing up a circle, we're just going to divide up a rectangle. So first of all, we have to see how our rectangles are divided. So let's just take 1 to 2. 1, 2, 3, 4, 5, 6, 7, and 8. So our rectangles are divided into 8. So let's put that as our denominator already. Well, we have 2 holes, and 1, 2, 3, 4, 5 of the 8 are shaded. So our first add-in is 2 and 5/8. Our second add-in is 1 whole and 1/8 because it's still divided into 8. 1, 2, 3, 4, 5, 6, 7, 8. Now if I add these together, so I'm going to add, and I'm just going to put my equal sign down here, so I'm going to add vertically this time. I have 1 hole, 2 holes, 3 holes, and 1, 2, 3, 4, 5, 6 of the 8s. Now remember, we can reduce this to lowest terms by dividing by 2. So we have 3, and I'm running out of room here, 3 and 3/4. My apologies. Okay, so that's how fraction strips work. If I want to find the total sum, I put them end to end on a number line, and I just count from 0 to wherever it ends. Okay, let's go on to this one. Write an addition equation. Okay, I'm going to fill in what's missing. You can see that it's 1 is divided into fourths, or the first add-in. So you have 1 and 3/4 for your first add-in. We are going to add our second add-in, which it looks like 3, 4, 5, 6, 7, 8. Yeah, that's about right, 8. So our second add-in is divided into 8s, and we have 2 and 1, 2, 3, 4, 5. We have 2 wholes and 5/8. Now in order to find the sum, we put both of these fraction strips end to end and we count from 0. So 1 hole, 2 holes, 3 holes, 4 holes. And let's see how it's divided. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. And 1, 2, 3. So our answer is 4 and 3/8, and that's in lowest terms. So in the next class example, we're going to shade in the sum, and then we're going to write the addition equation. So we have, in our first one, 1 2/3, and we're going to add 1/6. Okay, so we can already tell that it's divided into 6, so we know our answer is going to be in 6. So we're going to shade 1 whole. Oh, sorry, my apologies. I have to divide these in half, and then we get 6, because we have to make sure that our denominators are the same. The easiest way is if I have thirds, if I have 3 pieces, if I divide each of them in half, I now have 6 pieces. So now we have to shade in. So this is our whole from our red. And then 1, 2, 3, 4. 1, 2, 3 of the 4. So 4 out of the 6 were shaded in, and 1 of the blue. So this sum is 1 and 1, 2, 3, 4, 5, 6. So that is your addition equation. Remember, an equation has an equal sign. So you need your 2 addends plus your sum. Okay, let's try one more. So again, I'm just going to make sure that you guys see all of this. Now we're going to have to shade in our addends and everything. So let's shade in 1 2/3, so 1 whole, and 2 out of the 3. Again, my shading is not the greatest. And my second add-in is 3. Ooh, and 5, 6. So 1, 2, 3, 4, 5. Let's make that pretty clear there. Okay, so it's gonna equal to putting these 2 fraction strips end to end. But again, we have thirds and we have 6. We have 3 pieces here. We need 6 pieces, so we're going to divide each in half. Okay. So 1 whole from the red, 3 wholes from the blue. I hope you see that. 1, 2, and 3. We got the 3 wholes. Now from the red, let's go back to the red. Instead of having 2/3, we now have 4, 6. 1, 2, 3, 4. So let's shade those in. 1, 2, 3, 4. I'm just going to put in that 1 so you can see it. There you guys go. And from the blue one, we have 5, 6. 1, 2, 3, 4, 5. We have to put these here. 1, 2, 3, 4, and 5. So now if I start from 0, I have 1, I have 2 whole, 3 wholes, 4 wholes, 5 entire rectangles, and 1, 2, 3 of the 6, and that's your part. Again, divide by 3, you have to reduce that to lowest terms. Divide by 3, we have 5 and 1/2, and that looks right. You can actually see that in this rectangle, half of it is shaded. Okay, so that makes sense. So let's do this one, and yeah, that's just our last one. Now, I won't ask anything like this on a test, but I'm just going to show you how to do this. I'm going to enlarge the question. I'm going to write down my fractions here and, whoops, and enlarge the diagram just so it's a little bit more clear. I did this in class as well for the students, so just want to make sure you guys can see this, okay? Okay, so I think that's a little bit bigger. Perfect. So let's move that. Okay, so let's fill in. I think you can see that. So 3 and 5/9. So there's 1, 2, 3. And the 5/9. I'm just going to move that and put that one in so you guys can see it. So 1, 2, 3, 4, 5. And again, I'm not going to shade very clear because I want to see the little, how many I go. I want to make sure I see the ticks. In the blue, I have 1 whole, and then I have 2/3. Okay. Now, this kind of gives it away here, what to divide it into. But if I have 9ths and I have thirds, the best way to do this is by dividing each of the thirds into thirds. And then you have 9ths. So if you cut 3 pieces into 3, then I have 9 pieces. So I know my answer is going to be in nines. I just need to know how many. So let's try figure that out. We have 3 holes with the red, 3 entire rectangles, I can't pronounce today. And we have 1 entire blue, 1 whole blue rectangle. Okay, so now since I have blue, let's just deal with blue. 1, 2, 3, 4, 5, 6 now. So 1, 2, 3, 4, 5, 6. There should be a little tick there. Sorry about that. These were really hard to find on the internet. And then here we have to take care of this one. 1, 2, 3, 4, 5. So 1, 2, 3, 4. I'm going to put that tick in there too. And that's the 5. Let's just make sure. 1, 2, 3, 4, 5. Perfect. So starting from here, we have 1, 2, 3, 4, 5 entire rectangles and 2 of the ninths. So that's what it would equal. I won't give one like this on your test. It was just a little bit more elaborate. Like that is by far the toughest question that you would ever be expected to do pictorially. Okay, so now I'm going to stop the video and I'm going to go on to the third part to teach you how to do it symbolically.